Good evening, sir. Good evening, sir. Good evening, sir. I said it first. Natish.
Very good evening. Very
Sir,
good evening.
good
Good.
evening, sir.
Very. How are you, Sankar?
Sir,
How are you, Dish?
Yes, sir,
Yeah.
we are
fine,
fine,
sir.
sir.
Sir, actually, I finished the assignment, but I couldn't send it, sir.
Why? You couldn't send?
Sir, it's because after I finished the assignment, I had to go out for swimming class. Then I was like, I thought I would come home early, but when I came back home, it was like closed, sir.
Why, da? Hey, it's still Monday, 8 o'clock, da.
Oh,
Yeah,
Monday,
you
8
can
o'clock.
submit.
Oh, Monday,
Yeah.
8 o'clock. Oh, I didn't know that.
You just didn't look, you forgot, liar. Sir,
No,
I
actually,
couldn't submit because my parents are not even here, sir. My
Where are
parents
they?
went out of country, sir, so they can't send it, sir.
lol.
They
Nice
can't,
Okay.
they don't
information.
have signal in some places, so they won't. But I sent it to the management and then,
Bhaskar, sir.
yeah,
Bus.
Bhaskar, sir. I
Okay.
sent it to Bhaskar, sir, saying that my parents are not home. I sent all four assignments, chemistry, biology, everything.
Great then.
One second,
So
sir, I'll just go take my book. So Kongu will come like 15 minutes late, sir, he said.
why? Why? Why is he?
I didn't ask, sir. I think he's going outside or he'll come late. Sir.
I think he's coming from outside, not going outside.
When he called me, it's like sounded like he's inside only. So I'll just go take my book and take one.
Okay, sure.
Yes, sir.
Sir, new chapter, sir.
Yeah. Today we are going through new chapter. That is the periodic table.
Sir, shouldn't this chapter be easy or is it like tough? Sir, should we write in this chapter or is it enough to just refer at the book, sir?
No, you should write because when you write, writing makes you perfect. And whenever you write more, then you will remember more. If you don't write, then you will forget.
Yes.
Yes, I'm back.
Yeah.
Tarun
Sir,
is supposed to join. Kongu will add on.
sir, in this chapter for they already announced the tests, sir, for learning room.
Okay.
So, like for this chapter, will you like give us the uh, periodic table, sir? Like we can't remember all the elements, can we?
Yeah, you have not to remember all the elements. Who told you to remember all the elements? Remember all the elements.
You have to learn first 20, that's it.
Exactly, exactly. First 20, they are enough for you. First 20. You have not to remember all the elements yet. So, shall we start or wait few minutes? Is anybody
Let's
more
start,
joining?
sir.
I mean, Tarun
Tarun
should
Okay.
should
join.
join,
Kongu
but
said
he'll
he'll join.
usually join like very late.
Okay, okay. So
Kongu
in
will
this
join.
period, so first of all, this unit it is regarding the periodic table, right? So we had to discuss the elements, their properties, how the classification of elements it was given by the various scientists. Just we had studied the Dobriner traits, then the Newland's law of octaves, then the Mendeleev's periodic table, and then we will go through the modern periodic table. So first of all, can you tell me what is periodic table? Can you define what is periodic
Sir,
table?
it is a
So it's a
very
table.
no. It's a very for
Yeah, I'll tell the Poda. It's a table where they classify the order in which the elements are placed, like that.
Okay, I will write it
sir,
here.
in a
So a
very
table.
I
sophisticated
know
way.
you're. Yeah, I know
It
you're
should be
looking at the
very,
book. Yeah.
no. It
Okay,
should be very specific.
okay, no
Sir,
problem.
like
Just
each element has different like uh,
uh,
I looked at the book.
reactivity things, so that's why it
but
should be
all
arranged
those
in a very specific way.
yeah, actually all those elements which have similar property, they have been arranged in a particular group. So all the elements which are within a same group, so they have same property. This is very important
That was fun.
in this periodic table. So I will just define it that it is a tabular form in which elements are arranged.
Yeah, that's what
A
I said.
tabular form in which elements are arranged in increasing order of atomic number, right?
I'm pretty sure that's what I also said. So.
Yeah, in increasing order of atomic number.
Correct.
Increasing order of atomic number. So you have to remember
Sir,
that. Yeah.
sir, but for few elements, it is like 81, then 80, sir. Like just an example, it starts at 80 and 81. Like
Yeah, it will
the
be
num.
81. It is there.
No, sir.
Atomic number always in the
No, sir.
increasing order.
Sir, but I once saw an element where the the number ahead of it came before it, sir.
No, no,
What?
no, no. That's actually the mass number what you are actually talking of. This is the atomic number I am talking of.
Okay.
Top is
Mass
the
number.
mass number, bottom is the atomic number.
I
Exactly.
know that.
Bottom is that.
I know that. I think I got confused between.
That's what I'm saying.
Okay, I will write it. For example, if this is E is the element, you will remember that here it will be the atomic number Z and E will be the mass number which is above, superscript. Okay, so a tabular form in which elements are arranged in increasing order of atomic number.
Or proton or electron.
Yes, exactly. The number of proton, that is the atomic number. So if you just see in the periodic table, you will just find that hydrogen is here having atomic number
Yeah,
1, and you will, yeah,
that.
you will see the helium at the right side of the periodic table, atomic number 2. Then you will just
Lithium,
see
beryllium here.
yeah, exactly, lithium atomic number 3, then it is the beryllium, then it is the boron, then it's the carbon, then it is the
So why is
nitrogen.
hydrogen and helium alone written like that? So? Was there a title or something in the middle?
No,
What do you
actually,
mean?
it is actually due to the similarity in their property. For example, the property of hydrogen, it resembles with this lithium, so that's why it's placed with this. Similarly, beryllium, then we are having magnesium here, so property resembles. Beryllium, magnesium, calcium, strontium, barium, they have all similar properties, so that's why they are in the same group. This is your group number 2nd, this is your group number 1st. Exactly.
Sir,
This
the
is
bottom one is the mass number and the top one is the atomic number.
no, bottom is the atomic number, top is the mass number, A is the mass number, Z
No,
is the
sir.
atomic.
No, sir, but in our textbook, page number, in Nitish, page number 83, it's given in opposite way, sir.
That's not even a. Look at the periodic table at the back of the book. Oh, it's given.
How am I supposed to know that?
Periodic table, periodic table, they didn't in the book. The periodic table they given like a number, not at the top of the element, but at the top of the box. It's different, but the way you express it should be like this one.
The periodic table which you are seeing, it may be the Mendeleev's periodic table in which actually we have given the mass number, not the atomic number.
Yes, sir.
Exactly.
Sir, on
So
the top, the atomic number is there, and on the bottom, relative atomic mass
that's
is
only
there,
for
which
this
is
thing. Actual periodic table, the full spread one will be like this one.
it's not the actual one which you are seeing. It is not the in actual periodic table. You will see here the atomic number Z is the atomic number, and E will be the mass number, which is above top.
Yes, sir.
Okay, now see here that this periodic table, the important property of this periodic table is that the elements, they repeat their property after certain regular intervals. And what are those regular intervals? They are very important. For example, the regular intervals are 2, 8, 8, then 18, then again 18, then 32. These numbers are known as magic numbers.
What?
You will remember that these
sir,
numbers
there
are
is magic in physics. Magic in science. How does that make sense, sir?
It's a word. It's a phrase.
I will tell you that why they are known as magic numbers, because with these numbers you can just tell the atomic
Even
number
I'm
of
being
any.
sarcastic, Nitish.
I did ask it.
I am just saying that with these numbers you can tell the atomic number of any element in the periodic table. You are having 118 elements, right? So you can tell the atomic. You have not to remember the atomic number. Just you can tell with the help of these magic numbers.
So why do we need to remember the atomic numbers? It's just going in order, sir.
Okay, I will tell you. See.
It goes in one order.
See, for example, we are having the first period. We are having in the first period there are only two elements. That is hydrogen and helium, right?
Yeah.
That's why first we are having the 2. Then in the second period,
Is it 10 or 18?
18.
It is 18, not the 10. It is 2, 8, 8, 18, 18, 32, 32. Okay, now see here.
Like that it
In the
goes like
second
64, 64. Like that is
in the
keep
second
going.
in the second period there are 8 elements. Similarly, in the third period there will be also the 8 elements. I hope you remember the periods and the groups. Do you know what are periods and the groups?
Yes,
No,
sir.
sir. I know groups, but not periods, sir.
See,
Periods is
group
the
is
rows.
from top to bottom. That is horizontal. That is vertical column. But horizontal row, that is your period from left to right.
Yes, sir.
Horizontal is, I mean, vertical is group. Horizontal is period.
Okay,
Sir,
yeah.
how does period help, sir?
Yeah,
It's
it
another
helps
word
in
for us.
a lot of things. You can tell the general outer shell electronic configuration. You can also tell the number of elements in each period, and you can also tell the electronic configuration and the property which is related to that. I will tell you it later. We will go from basic to the advanced. So group is a vertical column. You have to remember group is a vertical column, and period is your what? That is a
The
horizontal row.
horizontal column. I mean, row.
Row, yeah, that will be
Horizontal.
horizontal row. Exactly, horizontal row. So vertical column, it is always from top to bottom, and vertical and horizontal row, it is from left to right, and the vertical column, it is from top to bottom.
Yes, sir.
You will remember it here that it's from.
Good evening, sir. Sorry, I joined a bit late.
No problem. Very good evening. So we have just started the new topic, new unit chapter, that is the periodic table. So I told that why it is known as periodic table. It is because it is a tabular form in which elements are arranged in increasing order of atomic number. So now see here, in this periodic table, you have to remember that there are two things. One is called the group. Group is a vertical column that is actually from top to bottom. For example, you are having
Yes,
this is
sir.
your group number first. Group number first has elements like hydrogen, lithium, sodium, potassium, rubidium, right? Similarly, group second, it has beryllium, magnesium, calcium, strontium. You have not to remember these all these elements. I will tell you that what you have to remember actually.
Yes.
Then you have to remember what is a period. So period, I told it is a horizontal row that is which actually starts from left to right. Left to right.
Yes, sir. This
So
is 7, right, sir?
exactly, exactly. In the modern periodic table, you are having 7 periods and you are having total 18 groups, right?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Groups will be 18 and periods will be 7
7.
only. Exactly. So shall I move to the next page?
Yes,
Now
Yes,
sir.
see,
sir.
first of all, see here that
Excuse
why
me,
these are known as
sir.
magic numbers. Yeah.
Sir, why is there a Roman number below the group, sir?
That is actually given by Mendeleev. We will discuss the Mendeleev's periodic table. I will tell you the Roman. Here it is not the Roman. I am just talking of this time modern periodic table. There isn't any Roman number. There are just these English numbers.
Yes, sir. Sir, I think they give the.
Yeah, I
I
think
think
they
they.
combined both the
I know they
whatever.
combine both modern and Mendel's, sir.
Exactly, exactly. We will see. We will study the Mendeleev's periodic table. Then you will know that why these Roman numbers. What are these? For which groups we are using? See here now the magic numbers. With these magic numbers, you can tell the atomic number of any element in a group. For example, hydrogen. You know that the atomic number of hydrogen is 1. Do you know
1.
that?
Yes,
Yes,
sir.
Exactly.
sir.
So you will just add the first magic number, that is 2. So 1 plus 2, that is 3. 3 is the atomic number of lithium. Got it? Then
Yes.
you will just add another magic number, that is 8. So 3 plus 8, that is 11. 11
Yeah.
is the atomic number of sodium. It's very
Yes,
easy and
11 plus
important.
8.
Yeah. Then you will again add plus 8. So 11 plus 8,
19.
that is 9.
12.
Yeah, exactly.
19,
Exactly.
bruh.
19,
12
19 is the atomic number of potassium.
Oh, wait. Plus 1. 4 plus 8
plus
plus 1, right?
18.
Then you have to add 18, 18, another magic number. So 19 plus 18, so that is 37. This will be the atomic number of rubidium. Got it?
Sir.
Yes, sir.
Then you will again add 18. So
Yes, sir.
37 plus 18, that is 55. It will be the atomic number of cesium.
55.
Yes, sir.
Exactly. So this is how it helps us to tell the atomic number of any element. If you don't remember, no problem. You can calculate, you can tell the atomic number of any element in a group by using these magic numbers. So you have to remember these magic numbers. So it is the 2, 8, 8, 18, 18, 32, and 32. Got
Yes, sir.
it?
Yes,
So
sir.
Yes, sir.
can you tell me that Where from these magic numbers have come?
Sir,
From
there
the
should be
periodic
some
table, sir.
formula, sir.
Actually, it is from the
Correct.
periods. How many periods we are having?
7.
7, sir.
Exactly. Can you tell me how many elements are there in the first period?
2.
2.
Exactly. There are two. So that's why the first magic number is two. Then in the second period, there are 8 elements. So
8.
that's why
8, sir.
exactly.
So,
In the third period, there are
so the
also 8.
magic
sir.
numbers are numbers that tells how many elements are there in a specific period.
Exactly. There are 7 periods. So in the first period, there are 2 elements. In the second, there are 8. In the third, there are 8. In the next, there are 18. Then again 18. Then 32, and then 32. Got it? So
Yes, sir.
can you just sum up these elements? How many elements will be in the periodic table?
Sir, 8 plus.
118.
Exactly, it will be 180.
Bro, you just saw the last
Hey,
one.
it's common sense that there's only 118 elements.
Sir,
It's
sir
Yeah.
just
told us to add those up there. You're
yeah,
not
Yeah.
supposed
but
to
it's
check.
common
You're,
sense.
but you're not supposed to just check the last one. Even
Yes.
I can check it, but sir told
I
me
didn't check it. I know
calculate it.
there's only 118 elements. What are you talking about?
Okay. Now, shall I move to the next page?
Yes, sir.
Yes, sir.
Only you would not know that there's only 118 elements, sir.
So yeah, now tell me, first question is that why there is need of classification? Can you tell me why there is need of classification?
So for better understanding.
Exactly, for better understanding and simplifying the things, right?
Yes, sir.
So why there
Organization.
That's why I
exactly,
said.
for example, when we just classify anything, it becomes very easy to study that, right?
Sir.
So, okay, I will write it here that why it is actually essential, why there is need of classification. See, first of all, when we just talk of 17th and 18th century, in 1800 there were only few elements. First there were few elements, then it went up to 30, then few more elements got discovered, it went up to 45, and then it went up to 56 elements. Then in the Mendeleev's periodic table there were 63 elements, and now presently we are having 118 elements, right? Now tell me that is it easy to remember all these elements?
No, sir.
No.
It is difficult. Very good. Now tell me that if I am just talking of one element, that is the carbon, atomic number 6. Do you know that this carbon, it reacts with hydrogen, it
Yes,
reacts with
sir.
oxygen,
Yes, sir.
nitrogen,
Hard.
similarly phosphorus, sulfur, and few other elements like fluorine, chlorine, bromine. Only these elements it reacts with.
Yes, sir.
And it forms organic compounds. These elements you will only see in the organic compounds. But can you tell me how many organic compounds we are having?
No, sir. I didn't study organic chemistry. I don't know about.
Yeah, there are 9 billion organic compounds.
So, but why don't all the organic compounds fall? Oh, it's a compound.
Organic compounds, yeah.
Sir. Sir.
Sir, all 9 billion of them discovered.
It's a compound. There's infinite amount of configurations. Actually, they're not there. Some are exceptional cases, but we don't talk about that. It's like a Rubik's cube. Like there's so many possibilities. Also, explanation good, Ra. Pongu.
You know why Tarun didn't come today?
To football class, I know.
Yeah.
I know. That's the first reason. Yes, sir. Good day.
Yeah, can you hear me?
Yes, sir. We can hear you, sir.
Okay, is the screen visible?
Yes, sir.
Okay. So now see here.
Okay. It's okay.
So we are having 118 elements. We are having lot.
It's
Yeah,
stuck
we are
on the
having.
digits screen, sir.
Is it now visible?
It's still on the widgets, so like
Is it now clear?
No, sir.
I think it's stuck, so it doesn't show the boards. It just shows that widget screen.
Why but? Okay, just wait. So is it now visible?
So are you showing the
No,
board
sir.
or just the video? Ah, we can see them. Sir. We can see now.
Okay,
Yes, sir. You can see. You can see.
great. So when we are having so many large number of elements and then their compounds, large number of compounds, right? So in order to remember these, then the properties of these elements, it was very difficult. So that is why scientists, they just classified these elements in order to simplify their study. So that is why there is need of classification. So we classify elements in order to make study easy, in order to make study easy and systematic, in order to make study easy. So you will remember this, and systematic. So that is why we just classify these elements, right?
Sir.
Okay, in order to make study easy and systematic, we are just classifying these elements. So the first attempt to classify these elements, so let's see the history of classification. In the history of classification, it was firstly the father of chemistry. Can you tell me who is regarded as father of chemistry?
I don't.
I forgot. Oh,
Dalton,
sir.
sir.
It's
No, no,
no,
I'll
it
just
is
check the book
sir.
real quick.
Anthony Levison, right?
Bruh.
Oh, yes,
Anthony.
sir. We learned it. I forgot.
We never
And
learned it. You learned it.
We never learned it there.
so
Yes,
it
sir.
is just
Yes,
the
sir.
top of 1800. So what he told that elements, he classified the elements into three categories. So he classified elements as metals, similarly non-metals, and
Noble
earths.
metalloid or noble gases. I don't know.
No, he didn't classify it as metalloids or semi-metals, but he just classified as earths. He told actually those elements as earths which were just found in the
Oh,
earth's crust.
like heat. I mean, fire. Then the
Bruh, their energy,
No, no.
dog.
element.
Just we are having this, let's say, aluminum, we are having iron, we are having, right, magnesium. They
So
actually
then
occur
what
in
comes under metals and non-metals, sir? Like I know
metals.
stainless steel.
All
Stainless
these metals, just potassium, you
steel
are
is
having
alloyed,
sodium
sir.
is a metal, copper is a metal, right? Silver
So
is a
aluminum
metal.
wasn't a metal then.
Yes, aluminum will also come here. Aluminum is also a metal, but he told it just that this aluminum, it is obtained from the earth's crust, so that's why he called
Oh, it's a
them as,
ore. It's not a purified aluminum. It's a ore kind of.
yeah, it's
Yeah,
actually
it's
obtained
found,
from the
sir, it's
crust.
found in the earth.
Yeah, it is found in
Found
the
in the
earth.
earth, right?
So fluorine, chlorine, bromine, they are your non-metals, oxygen, sulfur, nitrogen, right?
I don't get it, sir. How did he classify metals into earth, sir? Everything you get it from earth only, right, sir?
No, no, you don't get everything. Can you tell me where from you get the noble gases? Do you get noble gases from
No,
the earth?
sir, but everything is on or in earth, right,
Matter
sir?
can neither be created nor destroyed. So how did we create it? It was there.
Yes, sir, it was already there, right?
Yeah, it is there, but he just classified this on the basis of the source. So, what is the source of these elements? Source is the Earth's
Ground
crust.
or earth like that.
Exactly, Earth's crust. So you have to
Oh,
remember.
So where was sodium found, sir?
like
Sodium is also found in the rocks. Just we are
it's
having
very
the rock
rare.
salt, NaCl, sodium chloride,
The
rock salt.
rock form of sodium can be called from earth. The purified form
That is,
can be as classified as metals,
yeah,
right?
it is also obtained from there, but it is your compound. It is a salt, sodium chloride. You have to just tell the elements. This is the classification of elements only.
Yes, sir.
So this classification was not so much fruitful. Then the next attempt, it was given by very important, that is the Dobriner trades. That is very important. This is in your syllabus, and you had to study
Is there
from
a
there.
name?
Is there a name?
Yes,
Is there a name?
yes, yes. It is the name Dobriner.
Sir, that sounds like a
No
process, sir.
brainer.
Yeah, actually, these names are difficult, but when you just go through these, then it comes on your tongue. So it is
Sir,
Dobrynin,
it's Dobrainer what? No, sir.
Dobreiner.
What's after
Yeah,
Dobrainer? What's after?
It is the trade, TRIAD.
yeah,
Dobrynin trades. Do you know what is try? Try means three.
three.
Yeah, exactly. So what he did,
Are they twins? Are they twins?
classified elements into groups of three. So I will
Triads
write
is
it here.
not his last name.
No, no, it is not the
Oh,
name. Try means for three. Try. It is not the name. Name is only here. That is the Dobryner. It was actually the John Dobryner. The full name is John Dobryner. Okay, I will write it here. It is the John.
everyone had to be named as John in that day in those days, sir.
Exactly, exactly. For
Okay,
example, if you just talk of Dalton, it is the John Dalton. Exactly.
John.
If you just talk of the Newland, we have to study the next. That is also the John Newland.
So, but what
Exactly.
is Dobriner did? What did Dobriner do?
Okay, I will tell you what he did. He just gave the law which is known as law of trades. So he gave law which is known as law of trades. And what he did, he just classified elements into groups of three. Okay, I will write it here. What he did, he classified he classified elements into groups of three. So do you understand this? Into groups of three. So that means he just placed three elements together. And he told that these elements which he grouped together, that he told that they have similar property. For example, he just made a group of three elements. Here we were having the sodium, just lithium, then the sodium, and then potassium. So this was the one of the trade. So this is a trade, isn't it? It is one of the trade, or you can say tride. Tri means three.
Sir, so lithium, sodium, and potassium have same like
Property. Exactly, exactly. Okay, I will tell you what property they have. All these are metals. All are metals, right?
Yes,
all are earth
it's
metals.
almost as
Exactly. All are metals. All have valency one. So that means all have valency one.
that means it's like 4, 5, 6 balances. How did it
Sir,
happen?
but Antonio Lavoisier said sodium is a metal, right, sir? He never said it as an earth, but John Dobreiner said it as
Didn't Anthony
earth,
Lehman
sir.
discuss
There
this?
is some background noise coming. Yeah, these are all metals.
Yes, sir.
It's Anthony Lewis in the
Earth is like a
Lehman who
part of metals and non-metals,
Okay, it's okay.
Earth is
But
not
just
like
the source. It is just the source that you are just obtaining these metals from the Earth's crust.
it's
yes.
not like
Earth
Earth is
has
separating.
Yeah, that is just the source that these elements they are obtained from the Earth's crust. Now, the John Dobryner, what he did, he just classified elements into groups of three, and he called this as a trade, and he told that all will have similar property. And not only that, he just told one of the important thing, that is, he told that the atomic weight of the middle element. Here is the middle element, that is the sodium, right? He told that the atomic weight of sodium, it will be nearly equal to the arithmetic mean of first and third. That is very important. So shall I move to the next page?
Sir, how, sir? There are like many elements between them, right, sir?
I will tell you. You just note down this. Shall I move to the next page?
You're gonna go to the next page.
Sir, he can go to the next page.
Okay. So see here what he told. He told that, okay, first write down what he told. He told that the atomic weight of middle element, atomic weight of middle element is nearly equal to arithmetic mean of is nearly equal to
So, like, one of the elements will have atomic number of like 0.1,
arithmetic
0.5.
mean of first and third.
So, like that one is so.
Sir,
I
what do
will
you
tell you.
mean by middle element, sir?
Middle is that the trade which he has given, the element which is middle in this trade. For example, if you are having these three elements in this trade, that is the lithium you are having, then you are having the sodium, then you are having the potassium. So which is the middle? Middle is definitely here the sodium.
2 plus.
So now see here, what is the mass of, can you tell me what is the mass of lithium? What is the weight of lithium? It is 7, right?
7,
Yes, sir.
sir.
7.
Okay, what is the mass of potassium? It is 39. Now, can you tell me what will be the mass of sodium according to John Dobryner?
Okay.
So
It will be
40. So 46 by 2.
plus
23.
39 divided by 2.
So
So that
46 by 2, which is
Oh,
equal
it's the
to.
average.
Yeah.
average, yeah, average is called the mean. Yes, exactly. I told
Yes.
here that it's the arithmetic mean, or you can say the average. Average. So that is why we know that sodium, its mass is 23, isn't it?
Yes, sir.
Sir, can it just be anything? How do we know like it? Like, what should we put in there?
Prehistoric. What are you talking about?
You have to remember these trades. This is the trade given by John Dobryner, one of the trade, that is
Sir,
lithium, sodium, and
how do we form our own trades, sir?
he just found that these three elements they have similar properties, so he just made the trade himself.
Oh, so
There
we
isn't,
can't.
yeah, there is only the criteria that he just found that the properties of these three elements it was similar, so he just gave this trade. There are limitations which we will see later on, so first you have to remember. So this was the first trade. Now the next trade which he gave, that is the trade of calcium, strontium, and barium. I will write it here.
Calcium, sodium, and what?
Calcium, strontium,
Strontium.
and
Strong
barium.
element.
Sir, so these trades
Sir,
should always
strontium is
be.
like so much right, sir. There,
Yeah.
it's
Yeah, but when you mean it, it will become
mean it.
mean.
What is
I
mean it?
mean when you average it, when you average it.
You
Yeah,
did
when you
mean
just
it.
take the average, when you just take average of the atomic masses of first and third, you will just get that of the middle one, right? So middle is here strontium. Can you tell me what is the atomic mass or the atomic weight of calcium? 40, right?
Calcium
40.
40, sir.
Yes, sir.
Okay. What is that of barium? Barium is 137. I will
Radium.
tell
Radium.
DK.
BA. It is the barium.
Yes, sir. It's
Okay. Can you calculate the average?
88.
88. 88, 88.
So it will come out to be 80.
8.
8, sir.
8.
Will it
Sir,
exactly come to 88?
divided by
No, sir.
18,
Sir,
sir.
137 plus 40 is.
88. Sir.
Sir, it will become 88.5, sir.
8.5.
Exactly. But the mass of strontium is 88. Exactly. So it is nearly equal to. That is why I have written down that it is nearly equal to. Sometimes it will not come exact, but it is nearly.
But shouldn't it be divided by 18? Like, because. Oh. Okay,
You
take
have
up.
to divide it by 2 because you have to calculate the mean or the average.
Sir.
Basic math.
No, I thought like because it was divided by 2 in terms of the periods.
No. It is, you will
Sir, is
divide
there a
by 2 in all the cases. You will divide it by 2 in all the cases. For example, the next trade which was given by John Dobryner, that is that
Sir, should trades should be only of like the same type of elements, sir?
trade contains only two elements. Chlorine we are having, bromine we are having, and iodine we are having.
Hello, am I
What is that
audible?
noise, da?
Yeah, I know
Yeah,
Hey,
it was
you're
usually
making
a
it.
control.
No.
if somebody is having their
Yes.
noise, he can just mute the audio.
Not me.
Yeah, there is like there's a blue outline like on your video when you are like blowing into the thing, so we can see you're only blowing
Blowing
it.
into the thing.
Blowing into the thing. Yeah, you're blowing into it.
Everyone should. Yes,
Now
sir.
see here, the third trade which was given by John Dobryner, that is chlorine, bromine, and iodine. So can you tell me what is the mass of chlorine, the first element?
First element, sir, 35.5.
Exactly, 35.5. We know this, right? Okay, that of iodine, I will tell you it is 127. Now, can you calculate that of middle one?
12.
12.
It is 128.
12. So 35.5 plus 127 divided by 2.
Okay.
150. No, yeah,
80.
142.
So
It'll be 80, sir.
No,
5.
It'll
No,
be
yeah.
80.5.
so 71.25.
It will just come out to
You're
be
like 10 off
81.2.
the
71 now.
Exactly. But when you just see the actual mass of bromine, it is 80,
27.
right? It is 80. So that means it is nearly equal, right?
Sir, in the book it's saying iodine's mass is 127, sir.
Yeah,
Oh,
iodine mass
bromine.
is 1.
Oh, bromine.
Is-
80. 80. Sorry.
So this is a non-metallic periodic, like sorry,
Exactly,
reactor
exactly.
disease.
All these are non-metals.
Here these are
Chlorine,
right.
bromine, and iodine, they are all non-metals. So that's why I told that all the three elements which are in a trade, they
Yeah.
will have
It's like
same property.
orders.
Excuse me, sir. Am I audible?
It's the
Yeah,
order
yeah,
of non-metals.
you are
Sir,
audible.
Triads, sir.
sir, should like triads be like of same like the same type of element, sir? Like one weak
Exactly,
metal.
because trade, I told that all the elements which are in that trade, they have similar properties. So that means they should be identical. For example, if one is metal, other should also be metals. If one is non-metal, others will also be non-metals.
Sir, but what about metalloids, sir?
There's no
He
metal.
doesn't give, he doesn't give any trade of metalloid because most of the metalloids they were not discovered at that time. It is the talk of 1817. You will just note down this year. It is the talk of 1817.
Like metalloids were a thing.
Metalloids were not discovered at that time.
At the talk of 1817.
Yeah,
There
it is
was
the
a
talk of
mass.
1817. So shall I move to the next page?
What
One
happened in
second, sir. One second,
1817?
sir. 1 second, sir.
Just note down these.
So what happened at 1817?
They found out
happened.
there's something called as trades in
John
chemical.
Dobrener gave the law of trades. So law of trades was given in 1817. Law of trades. I will write it here. Who gave this law? It was given by
John
Dobrinus.
Dobreiner.
John Dobrener.
Dobrinus.
You have to repeat it. It will then
Sir,
be
it
easy.
sounds like you're cursing someone, sir. Like Dobreiner.
What Uncle No Brader from now on.
I'm
You
smart.
have to pronounce it many times, then it will just you will
John
remember it.
Dobrinus.
So shall I move to the next
Yes,
page?
sir, you can go to the next.
Almost done, sir. 1 second.
Hey, how long?
Start writing when first teaching that.
I
It
am.
helps.
I was doing all the time. For one time, I don't do it, and you guys are like
Tarun can write faster than you.
I'm just giving a tip. I'm just giving you a tip. Not blaming you.
full tips by Kongwil.
Shut
Yes,
up,
sir.
and
Done,
write.
sir.
Shut up. Yes. You can go to the next.
Okay, so now what is the limitation? Can you tell me the limitation of this Dobrener classification?
Okay, like all
So what's the
elements
point of
not-
this, sir?
to find the
See,
mass number.
so what he did actually, he just classified elements into groups of three. But when he just made the trade, he just gave only three trades, right? But elements were more than that, right? Elements were 30 at
Yes,
that
sir.
time, 31 elements. So that means this law of trades, it is limited only for few elements. So I will write it here that it's limited only for few elements.
Limitation is limited.
Oh my god.
Only for few elements. It is only limited to few elements. That means we cannot just made the trade for all the elements which were discovered at that time, right? So for example, as you told that
If
what
there
is the
was
trade?
30 elements, he could have just come like did the same thing for all 30 elements, like sir.
It wouldn't work.
It wouldn't work. That's why there is limitation. For example, if you were having 31 elements at that time, but he couldn't make all the elements into trades. He
Because
just
there were
made only he just made only three trades, which I have given. That is the lithium, sodium, potassium, calcium, strontium, barium, and the chlorine, bromine, iodine. So he couldn't arrange all these 31 elements into trades. So this
Only
is one of
nine.
the yeah. So this is the
what he
this is the limitation.
Strontium, it was invented, I mean discovered back then.
Strontium.
Yes,
Yeah, probably.
strontium. You can, yeah, also call it as strontium, but strontium. Okay,
So the magical numbers were not like discovered back then because
There are not that
they
many
were
digits.
not in order.
exactly, because
Yeah,
all
they didn't
elements
believe
were
in
not
magic.
The
at
one is
that time.
it's easy to organize.
So then the next classification was given by Newland. So I will write it here. Next
One
classification.
second.
John Newland.
Exactly. It is
So
also,
we
but
like Johns.
it is here JOHN. In case of Dobrener, it was JOHANN, but here it is JOHN. So it is John Newland.
Famous Johns.
John.
Yeah. It is the talk of 1865. Law of trades was given in 1817, and now it is given in 1865. And what he gave another law that is known as law of octaves, right?
Octave. OC.
Yeah.
So there was 8.
So in 1865 noble gases were found.
Noble gases were not discovered at that time. In 1865, noble gases were not discovered.
Sir, when octaves are there,
Oh,
noble gases should be there. Like
no.
octet
Still they
Octave
are
is
all
typically
eight.
means
common.
Octave is eight. I will
Octet
tell you
and
why it was.
octave are different,
I will tell you why it is known as law of octaves. The reason is different. That is not actually here that noble gases there should be octet rule. No, it doesn't relate with the octet rule. There is something different. I will tell you that.
That also wasn't
So
discovered.
so what he did, he arranged all the elements in increasing order of atomic weight, and then he just found that the property of every eighth element it is similar to that of first. So that's why it's known as law of octaves. So I will write it here that
How many?
he arranged
Yeah, but how was it similar, sir?
I will tell you, he arranged all the,
it always follows a pattern, right?
yeah,
Oh,
it
One, two,
follows the
three,
but
all
one,
the
two, three, four, 3, 2, 1,
in
0, 1, 2, 3, 4, 3, 2, 1, 0.
increasing order of atomic weight
it does not follow a pattern.
Bro, what do you mean?
The
It
mass
does.
number.
the
It does,
properties.
yeah.
See, first is 1, and then 4.
Uh-huh.
That means 3 is difference. And then next is 7. That means again 3 is difference. And then 7 to 9 there is 2 difference. And then 9 to 11 there is
Every
again
eighth element
2 difference.
I think twice there.
What you said again?
No, like,
Tell.
wait.
How are they in order?
I don't speak that.
I mean, how are they in
Sangat,
so
stop
having
speaking
noted
like
down
that. You
this
can write. That's what I'm
are
telling you.
similar to the
I'm
first
writing
one.
there.
So this is the statement which John Newland gave. So what he told, he just told that he arranged all the known elements in increasing order of atomic weight. And then he found that the properties of every eighth element. So it was just similar to that of the first one. So I will just write here the elements, what he actually arranged. For example, he just placed lithium here, then beryllium, then boron, then carbon, then nitrogen, then oxygen, and then fluorine. So can you tell me how many elements are 1, 2, 3, 4, 5, 6, and 7? Exactly. Now the eighth element, he just placed it here because its property, it was just similar to that of lithium. So that's why he placed it here. Then he placed it here magnesium, then aluminum, then similarly silicon, then
Sir,
phosphorus,
so
then
so
yeah.
lithium was the first element discovered, like the first one.
Can I
No,
see?
No,
hydrogen was
No.
it,
not yet
An
discovered.
example you
it is it is not the first one. He just arranged these elements, and then he just told that lithium, sodium, and then the potassium, they have similar properties. So that's why if you just remember the law of trades, what was the trade? Trade was that of lithium, sodium, and potassium, right?
Yes, sir.
uh,
Exactly. So
So
that
that
means you can,
basically do
that means
not
that,
previous.
yeah, that means you can also see the trade, Dobrener trade in this Newland's law of octaves. For example, you are having magnesium, then calcium, and then what will be the next? Next will be here the strontium, isn't it?
Yeah.
Yes,
Yes,
sir.
sir.
Exactly. And similarly, if it is here chlorine, what will be the next? It will be bromine, and then what it will be?
Down and then
Iodine.
I
So that this is the very important point to be noted down. This is actually asked in your exam, that does Dobrener trade also come in the Newland's law of octaves? So your answer
yes,
should be
sir.
yes. Exactly. So
So
now
lithium,
have you
sodium,
yeah,
potassium
have you
is
noted?
a triad.
Yeah. So see here, lithium, its mass is 7, right? Then we are having beryllium, then boron. So you can see that when you just increase the elements, when you just arrange the elements in increasing order of their atomic weight, what happens? This is the fluorine is the seventh element, eighth is the sodium. So the first element, if I just call this lithium as first element, then my eighth is sodium. So the first and the eighth element, they have similar property. And how he just explained this, he just told that it is just like the musical notes. So do you remember what are musical notes?
So
The
no.
Yes,
magical
sir.
notes, sir.
No,
What
no,
is
Musical
different?
note.
musical,
What
musical
are
notes.
musical notes?
So it's
A,
like
Okay,
C,
B.
C
It's like
sharp,
that is
B,
E,
the
D
sa,
sharp.
strong,
re,
Oh, okay. Sir, why,
yeah,
why are you including this?
ma,
sari, gamma.
pa.
The
Okay,
Sampath
next.
is a classical singer, sir.
So that gets a singer.
Right, sir. How am I supposed to relate music notes with chemistry,
Yeah, yeah,
sir?
it is actually
Sari,
the
gamma,
German
father.
man, John
Sir, there
Newland.
should
He
be
just,
another sa, sir. There should be another sa.
sa is another, that is the repeating sound, that is sa, re, ga, ma,
Oh,
pa,
oh,
da,
oh,
ma,
oh, oh, oh.
yeah,
What does that have common with these?
yeah, there
No,
is
it's
common.
following that pattern. It's basically
What
Yeah,
following that
pattern?
pattern.
so can you
See,
just tell me?
after pada ni again sa will come, which is the eighth one.
Exactly. Exactly. So that is why you have to remember that just as in case of musical notes, the eighth musical note, eighth musical sound, that is similar to that of first. So Sam is here that lithium, it is the first element, sodium is the eighth one, so it is properly related to musical
Hello, sir.
notes.
Your voice
Got
is
it?
breaking. Only
Sir,
for me.
can you
John,
yourself
sir,
explain?
John Newland must know Carnatic music, sir.
Okay.
Can you yourself explain me what does that musical notes have in common with these periodic? And you shut up, the
Is
uncle.
it? Is it
Uncommon.
eight things?
Sir, can you tell so?
Yeah, I'm just telling that the eighth musical note, it is similar, just the eighth sound is what? It is again repeating, that is the sa. So it is the same that when elements are arranged in increasing order of atomic weight, then the eighth element, it has similar property as that of first. So
But
that's why
Sir,
he
but
just
has
sir, but then
similar
above
properties
and
as
then
sodium.
again above magnesium there should be a sa. No.
no. So see actually here what actually happens. For example, if you just take beryllium as your first element, so can you tell me what is the eighth element? Beryllium is the first. So what will be the next?
Sodium.
It is second, third,
It'll be
fourth,
magnesium.
fifth, sixth, seventh.
Oh,
Kongwell,
yeah,
again.
magnesium.
Yeah,
From when it's like
magnesium will be
sa,
the eighth.
ni, da, pa, ma, ga, ri, sa, and k will again be sa.
Exactly. So
Instead of
this is
doing
very important.
musical notes, we can just count till 8 and then we'll get it.
Yeah, you have to only
We
count
can do
up
it
to the
quickly with this step.
seven.
Like sorry, okay, this one only.
So have you noted down
Example,
this law?
Yes, sir.
invigilator be like, why are you singing?
Shall I move to the next page?
Yes, sir.
Now tell me the limitations of this. What were the limitations of this
You need to
classification?
learn music to understand this.
John Newland did know Carnatic music, sir.
Okay,
So this
there
is
is limitations like
now
makes
what is the limitation? Limitation is that this this trend, it is actually following up to calcium. After calcium, it is not following. That means after calcium, every eighth element, its property will not be similar to that of first. So you will remember that it is only applicable up to calcium. It is only applicable. It is only applicable up to calcium.
Sir, so that's why on up to calcium,
We
the
have
it
made
is like
exactly.
a space is given.
Exactly. I have just made this classification only after calcium. Some books write after the calcium, but it's actually having limitation after
Sodium,
calcium.
titanium, vanadium, chromium,
Yeah,
magnesium, like that.
exactly. Those elements they are not actually repeating the property after every eighth element, so that's why it's only applicable up to calcium. You have to remember this. This is very important.
Yes, sir.
So can you tell me what is the mass of calcium? 40.
What
So
Sir.
that means it's only applicable up to mass 40. You can also write like this, right?
Sir, I
after
have a
40
doubt,
there will
sir.
be no stuff.
Okay, tell me. What is the doubt?
Sir, in the periodic table,
Yeah.
the element actinium, it's present
Mhm.
both in the normal periodic table and in the acetinides periodic table, sir. How?
Yeah, when we will just move towards the modern periodic table, I will just tell you. Actually, that is the actinium. Actinium has properties similar to that of a block element, so that's why it is just placed there.
It's a
It's the,
bracket,
is it the
What is the atomic number there?
Actinium,
89,
it's 89.
actinium atomic number is 89.
and then mass number 227.
I asked
Yeah.
only the atomic number. Yeah.
I'm saying only the mass number. You think I'll follow
So
your
like,
order?
is it the only thing that's present in both the normal one and the bottom block one?
No, these are two elements. One is your lanthanum, atomic number 57. Another is the actinium, atomic number 89.
Only 57 and 89, sir.
Yeah, exactly.
Oh,
I will
okay,
tell
sir.
you the reason at that time when we will just discuss the modern periodic table. You just tell me here the limitation. So, what is the second limitation?
It's
Mm,
limited to.
A few elements only.
Yeah, that is only up to calcium. I wrote that. Next limitation is very important. So, can you tell me at the time of New Land, how many elements were discovered?
40.
31.
56. 56.
56. 56. You have
Hey,
to
you
remember.
saw from book, don't lie.
Hey, we wrote it. What are you talking about? We're not
When
2 seconds.
did we write that there?
You
Hey,
have not. If you just remember my
the
these
30,
wordings
45, 56,
in the
53.
in the first, I just told that there were first few elements, then there were 31, then in the new land
5,
it was 56, right?
63, and then 118. Yes, sir, you did
Now
say
what
so.
he told that only 56 elements exist in nature.
Only.
Yeah, so this was the biggest limitation.
I'll kill you if you don't follow my rule. He said that third limitation.
63 came.
And
Oh my
scientists
god.
killed him.
So what he told that in nature there will be only 56 elements, but that is not the case. We are having 118 elements yet, right?
Now the modern periodic will tell only 118 elements exist.
Yeah, so that is why this was the limitation that he told that only 56 elements exist in nature, but that is not the case. We are having yet
Now,
118, but in the future, few more elements can also be discovered.
Yes, sir.
Yes. So
but now
what is the next? Okay, what is the next limitation? Next limitation is that what he did, he just noble gases were discovered later on. He couldn't accommodate those noble gases in his
it's
classification.
like nah.
So noble gases
Sir,
I
without
left
noble
out.
gases, how did he do it, sir?
they were actually discovered later on. Later on, they were not
Sir,
discovered at that time.
no, sir. How
Noble
did he do that noble gases? How did he do the Sarigama Padanisa thing without the noble gases, sir?
Why
because
did he?
noble gases were not discovered at that time. So noble gases could not be
A. It's only
arranged.
applicable till calcium. Is there any
Yeah,
noble class? I mean, there is, but
What
still,
are you
he
talking?
forgot about it. He was like,
that was
nah,
not
man.
discovered.
He was
See,
like,
see, after calcium, there are two noble gases. One is the helium and neon, but they were not discovered at that time.
left out. Like Sankal.
So noble
Sir,
gases,
your argon is there, sir. Argon.
argon, argon is there, helium is there, neon is there, but they were not discovered at that time. It is the talk of 1865.
So basically, this guy's law is completely wrong because the eighth one is not has similar
Hey, do you
properties.
know a metal called abylium?
I don't care.
It's not there yet. It'll come only at 2075. See, that's how it comes. You don't know what's coming there.
No, sir, his law is wrong, right, sir? Like,
Wait, how does he know that?
yeah, but now we know it's wrong,
Now
right?
he's wrong. Now he's dead.
Yeah, it's actually at that time he just gave this classification. Now we can easily tell that there it is not actually the correct, but he just this was the attempt by Newland that how he arranged it. So we have to just go through the. It is just the history of classification.
Sir, the only scientist I know who didn't fail was Newton and Einstein, sir.
Do you know any scientists that didn't die yet?
My
Can you tell me?
grandfather did.
And there is only one scientist who have just got two Nobel Prize. That means without sharing with anybody.
That
Unsure two Nobel Prize. Can you name that?
Einstein, I know that. He
he's
got
dead.
that Nobel Prize.
No, it is the Linus Pauling.
Is
Oh,
he alive?
Linus Pauling, he has got two unshared Nobel Prizes. Do you understand this unshared? Nobel
Unsure.
Prize it is always shared between two or three scientists, but Linus Pauling, he has got two unshared Nobel Prizes.
even Einstein got it alone, right, sir? I don't know.
But not two, right?
Two is better than one.
Yeah,
Oh, I got two unshared Nobel Prizes.
yeah,
Is
yeah,
that
it is two.
Sir, but to get one Nobel Prize, you have to become like, you have to wait for a long time, right, sir? How did he get two, sir?
so smart,
That's why his contribution is actually very large. Contribution is very and
No,
that
sir,
is why
when you're 30 years old, you're a scientist and you discover or invent something new, and you have to wait for 50 years just for the Nobel Prize people to recognize yours and treat yours as an actual
what
law.
I
And
invented.
then you wait for 10 more years for them to give the Nobel Prize, sir.
How
exactly that is the criteria today. That is criteria today. It was not at that time.
you like invent two things and then first show one in a Nobel Prize, and then in the award ceremony you show your other invention, and then you
It's
get
not that easy. Getting a Nobel Prize is
not
what?
now, not
Getting an
now.
SOF certificate where you failed or what?
In the caveman days. So you can continue, sir.
Okay, so have you noted down these limitations?
Yes,
Yes,
sir.
sir.
Okay, then we have to study the Mendeleev's periodic table. That's very important. But I think we will discuss that Mendeleev's periodic table in the next class, right? So just let's revise. So what we have studied, we just first I told that what is a periodic table? It is simply a tabular form in which elements are just arranged
Increasing
in
order of
increasing atomic number. And then I told what is a group, what is a period. I told that group is a vertical column and period is a horizontal row. There are 7 periods in the modern periodic table and there are 18 groups in the modern periodic table. Then I told that it was just first the Anthony Levison, who is regarded as the father of chemistry. He just classified elements into metals, non-metals,
Sir,
and earths.
I thought he was the father of classifications.
No, no, Anthony Levison, he is the father of chemistry. I will note down it here. You have to also note down. Anthony Levison.
sun be like
He is regarded as father of chemistry, father of modern chemistry.
Son of
modern
chemistry.
chemistry. Yes, sir. He wasn't even alive now, sir.
Sir, yes, sir. How is that possible? Oh,
Why?
father. Oh, sir, father of modern chemistry means modern chemistry is like the sun. You get it, right?
What?
You don't get it. You gave the base. You gotta include
Okay,
some
okay, I get it.
biology
I
into
get it.
chemistry for it to
I
understand.
that Anthony Levison is the father of modern chemistry. Then can you tell me who is the father of chemistry then?
Dobrinus.
Which one?
No.
Dobrinus. I think
No,
so.
no, 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 no,
Selenius Pauling.
no, no. Pauling is also not.
The new learner. I mean,
Okay, I will write it here.
Dalton.
That is the Jabir bin Haya.
Who are these random people, sir?
They're more
They-
famous than you now. What are you talking?
Sir, in sixth standard, it was very simple. Had to remember two scientists, John Dalton and Rutherford.
okay, only those two.
Fifth standard was easier. Chemistry.
So just remember these two, that Jabir bin Hayya, he is regarded as father of chemistry, and Anthony Lavoisier, he is regarded as father of modern chemistry. So I hope that you have remembered the Dobriner trade. So what is that? That is the law of trades. What he did, he just classified elements into groups of three, and then he told that the atomic weight of the middle element, that is the arithmetic mean of first and third, right? And then I told about the Newland's law of octaves. So what it states that when elements are arranged in increasing order of atomic weight, then the property of every eighth element, it is similar to that of first. He just resembled this with the eight musical notes. Just as the eighth musical note, it is just similar to that of the first one. So same is the case here in case of elements.
At that time also, or we just doing it to understand.
Yeah, you have to remember the limitations. Limitations are actually asked in the exam. So what is the limitation of Newland's law of octaves? One is that
Only
it is
up to
only
56
applicable up to
atoms.
calcium. Yeah.
Only 56 elements are there.
Yeah, he
But
just told that only 56 elements exist in nature, but that is not the case. And similarly, noble gases could not be arranged in his classification.
Yes,
so what
sir.
does musical notes like did by what is this John Newland, or did we do it just for our understanding?
He just compared these properties with musical notes. He doesn't discover.
What did that?
New musical notes, that's why he just compared it.
He just compared musical notes. He just compared with the musical notes. Just by having the sari, Gama Pada Nisa.
Call Mozart and ask him to make a beat.
Yeah. So have you noted down this all?
Yeah, sure.
Okay, then let's stop today's class here. Yeah, any question?
Hey, Nitish, you remember like how what's this guy's name?
Huh?
1 second. So you remember Antonio van Leeuwenhoek, when he saw the cells, he was like, "These looks like the cells in the monk." When this guy, what's his name? I keep
Anthony
forgetting.
Lavoisier.
No, sir, the other guy's name.
Jabir bin Hayya.
No, sir.
Then Linus Pauling.
Yeah, Antonio Lavoisier. Yeah, he like sorry. Newland, John Newland. He saw the things, and he the first thing he thought was of music notes. Sir.
Yeah.
Oh, why did you tell a whole story just to do that?
Make you inspired. Thank you, sir. Bye, sir.
I didn't
Okay,
listen
bye.
to it. Thank you, sir. Bye, sir.
Most welcome. Bye.